Hi there, let's learn about Hertzsprung-Russell diagram today. What is Hertzsprung-Russell diagram? It is a certain simple diagram that represents the stellar classification according to what temperature and luminosity of the stars. You can just simply describe the star using this method. Very simple. How good? So according to my axes, there are two axes, x and y axis. So in the x-axis is the temperature T, and in the y-axis is nothing other than luminosity L. There are so many things to be known, but for O-level levels, you don't want to know too much of it. So let's learn. And another important thing you should know in here, it is that the diagram is a little bit weird. Why? Normally you start with the lowest value to highest value. Here it is not like that. It is the thing is about starting up with the high temperature and ended up at the very low temperature. That's the most really important and really interesting part. And the zero, not the zero level, actually the unit 1 is supposed to be the middle range stars like us and yellow stars are supposed to be the 1, and you don't even know about this one. Then an upper region is supposed to be something with high luminosity, and relatively smaller lower luminosity stuff is mentioned in bottom of the y-axis, lower. Okay, now let me describe you the locations of the star classification according to Hertzsprung-Russell diagram. There's a thing called main sequence. It's a very simple line and region like this, normally a safe one. For the O-level stuff, you don't really want to know too much of it. And what is main sequence? Main sequence, MS. What is the main sequence? Main sequence is the active phase of the life cycle of the star. That means the pressure, outward pressure, and gravitational pull as in an equilibrium. Like R on Sun is in the living phase, actually the main sphere. Right. It's main sequence star. Now you have to classify some other stars according to the star. Now you say the blue giants, very enormous stars, blue giants are located in the top of the main sequence, and the yellow stars like our sun located around this region. It's a yellow dwarf, actually, yellow dwarf, and so this region is full with what? It's relatively cooler but enormous objects called red giants. Actually, this region, the star is in the dying phase, very old ones, and red supergiants, extremely enormous and relatively extremely cooler, right? But the temperature is very higher scale, but others are compared to stars. It's really cool. That's right, because it belongs to some middle range temperature. And you can say very important thing called white dwarf. They are really extremely hot objects, but the temperature is very enormous and the luminosity is extremely low. Because why? Even though it exceeds high energy, but the star is very smaller compared to the Earth. It's normally white dwarf is in size of the Earth or smaller than that, little bit bigger. For example, is a Sirius B. Sirius B star called Fragile, very beautiful one. And Sirius A, actually, it's located just above our sun. It's the very brightest star that we can see with our naked eye. Is Sirius A. It's a kind of massive star compared to our sun, very bright. And some other things like Canopus, located in that red giant phase, that means red supergiant phase. canopus. I have to tell you something about the main scale again. So the main sequence, the star is the living one. The hydrogen fusion is taking place in this one. Once the hydrogen fuel is over, it becomes a red giant or supergiant according to our mass. Think about blue giants, and those things are going to be red supergiants, and the our sun and Sirius A types of stars are going to be red giants only. At the end of the life cycle, the star becomes a certain white dwarf and finally ended up being a black dwarf. That's how the life cycle it is. The size is very low, but temperature is very low for black dwarfs. These are the very simple things that you just need to remember. It's no rocket science in this one. For finally, let me explain you one of the important thing here is the temperature is very high at the leftmost part of the Hertzsprung-Russell diagram. In the rightmost part, the temperature is extremely low, and the luminosity is higher in top of the order, and luminosity is lower in the bottom of the y-axis. This is all you just need to know, and extra clarification, just remember Sirius B as a white dwarf and Sirius A as a main sequence star, and the Fragile is dying star, and Canopus is a giant, red supergiant. That's what you just need to know all about Hertzsprung-Russell diagram. I have explained this thing in detail about the life cycle of a star in another video. If you are interested in, just watch it and like and subscribe to my channel.